will see the types of gears. So actually there are so many different types of classifications available, but we here do this classification based on the the position of the shaft and their alignment. So what does it mean? For example, if I take this is the gear 1 and this is the gear 2, this gear 1 and 2 are attached to the shaft 1 and 2. So how are these shafts positions and how they align with respect to each other? So depending on that one, we can classify the gear. So here in the first section, these two are parallel shaft. Within this type, the first one is the spur gear here. So what is the spur gear? So here the tooth profile or this length of tooth. This is the tooth one and this is the length of tooth. So this length of the tooth is parallel to the shaft here. So if the length of the tooth is parallel to the shaft, then it is called as a spur gear. This is the spur gear in the action or in the engagement. So here this shaft and this these two shafts are parallel to each other, and this is a spur gear. And see, if you see the engagement of the spur gear here, these this one is exactly matching along with this teeth of the tooth of the other big gear. So even as soon as they engage, their contact is all along the teeth length, all along the tooth length. So it will happen suddenly, and it will happen suddenly, and so whenever it happens suddenly, then its action is rough. Its action is rough, and because of this rough action, it is suitable only for the low speeds. Low speeds, and since this initial engagement is all along the length, there would be forces more forces developed in this one, more forces, so that it ultimately leads to the stresses in the tooth. More forces, so that stresses in the teeth. So and here in this one, this is the externally engaged spur gears. So when these are two are externally engaged, if this one is rotating in this one, this will rotate in this direction. These are internally engaged. When these are internally engaged, these two would rotate in the same direction. For example, this is rotating in this direction, and this outer gear, this is also rotates in this direction. This is rake and pinion. Generally, what is the meaning of pinion? In any gear system, whenever two gears are engaged, generally the driving gear or the smaller one, generally the driving gear would be the smaller one. So the driving gear would be called as a pinion, and the driven gear is called as a gear. Here in this one, this is a pinion, and here instead of this is a gear, this is a gear with the infinity radius. For example, the radius of this one is a finite, but if the radius is very infinity, then it will turn into the straight line here. So this became a straight line gear. So this is nothing but a belt drive. So here the rotational motion of the gear is transmitted into the translation motion. So if the gear is rotating like this belt will translate in this direction. This is a good example of this pin and a rake. The next type in the spur gears are the when the shafts are parallel is a helical. So what is the helical here? Here the teeth line is instead of parallel to the shaft, here it's making an angle, so that angle is called as the helical angle. And here if you observe, the teeth line is straight as like in the spur gear, but the only difference is it's making an angle which is a helix angle with the shaft axis. This is the shaft axis and it's making angle like this, so this is the alpha. So these type of gears are called as a helical or spur gears. And how they react when they in the when they are engaged in motion. So see, if you observe this helical axis or the orientation of this one in the different direction of the other gear which is in the engagement here. So what I'm trying to say is, whenever two helical gears are in engagement, their orientation are in the opposite direction. And here one more no important point is, at the starting of the at the beginning of the engagement, only the tip is comes into contact initially, so that not whole amount of force is transferred to the other gear, but instead very small quantity of force is transferred. So the beginning of the engagement is very smooth compared to spur gear, spur gear. And because of this smooth, this is a no noisy. So when the both gears are engaged, this is the force. For example, this is a force vector that is acting in this direction, but this force vector is perpendicular to the teeth line here. This is a perpendicular to the teeth line, but this is a not perpendicular to the shaft axis. This is the shaft axis. So this is the shaft axis. So if I draw here, this is the shaft axis, this is the teeth line, and this force is perpendicular to this one. uh, so when this is a perpendicular to this one, uh, if I draw forces like this, so we have a force in this direction, because this is a alpha value. So we have a force component in the direction of the shaft axis. So because of this force component in the shaft axis direction, we have a axial force generated in the case of engagement of the helical gears. So that is a disadvantage. And here we can use much more higher speeds than the spur gear here, because the engagement is smooth here. In case of a single helical gears, what is happening? It's producing some axial thrust. But here what we did is we took double helical, two helical attached to each other. So this is in the one direction, this orientation is in the one direction, and its orientation is in the opposite direction. And these two are simultaneously engaging with the two other double helical gears. So what happens? This will produce axial force in this direction, and this will produce axial force in this direction. So both will get cancelled. So this herringbone or the double helical gear would be used for the cancellation of the axial force.